Hey, welcome back. It's SV Math Teach here. Remember to like and subscribe if you like these free videos. Today's video is on relations and functions. Now, this is kind of a tough one to get our heads around because, well, relations are kind of everything we've worked on for the past few years. Functions are a subset of relations. So let's get into what that means. A relation is a set of ordered pairs or multiple ordered pairs. Essentially, a relation is any relationship where two numbers are related to one another. So if you see a graph, you have a relationship between your x-axis and your y-axis. That makes it a relation. If you have a table, that makes it a relation because you have a relationship between what's in the left column and the right column, or the top row and the bottom row, however your table is arranged. So everything we're going to work on in this video is already a relation. Every single thing, right? Everything is going to be a relation. A function, however, is a little different. A function is a special kind of relation where every input, that's the left-hand column in a table of two columns. Each input has exactly one output value. Now let me see if I can show you examples to drive this point home. I have two examples here. An example of a function on the left, and an example of a non-function, but a relation only on the right. Now on the left, I have a comparison between how long you spend parked in a parking garage and how much it costs to stay there. And it shouldn't surprise you that the longer you stay in a parking garage, the more money it costs you. But you might also understand that if I added another item to this, 4 hours and 1 minute, the cost might still be $12. That's fine. We're allowed to do that, right? 4 hours and 2 minutes, 4 hours and 3 minutes. That might all be $12. That's perfectly acceptable because at the top, we have our definition of a function. It's a relation where each input, that's the number on the left, has exactly one output. That's the number on the right. Now look at the one on the right-hand side. This is an example of a relation only, but not a function because of the things in red. I have a comparison between the age and the weight of young kids. And what you notice, and this shouldn't surprise you, is that there's two 9-year-old kids that weigh two different things. That happens all the time. That's not wrong. That's not bad. It just doesn't follow the rules of being a function. So look what I have written below each of these two tables, right? The table on the left is a function. I wrote down that cost could be predicted based upon time. Cost is a function of time. Notice how I said the y, I kind of said the second value is a relation of the first value. Cost is a relation of time. This relation is a function. It's both a relation and a function. Look on the right-hand side. I'll use red because it's an anti-example. It's a non-function. Weight cannot be predicted based on age. Weight is not a function of age, and it's not because I see these pair of 9s to two different values. And this is a relation only, not a function. Now, rarely are you going to see as a student all of that different explanation. Most of the time you're going to see tables and it's just going to ask which one or which ones are a function or which one or which ones are not functions. This one says which of the following shows a function, y of x. So we're going from this one to this one. That's kind of how it's said. But when we do it, what we're looking for is I'm going to highlight, I'm going to look down the left-hand column and I'm going to look for any instances where I have the same number. As soon as I see that I have the same number, in this example I have a 9, if this number and this number are not identical, then it is not a function. It would be considered a relation only, right? R-E-L, relation only. And again, not bad, just not a function. Look at the second one. Look down the left-hand column, right? We're looking in the X column. Those are what are considered your inputs. Look at this one. Notice how there's no duplicates. 1/2, 1.2, 3.1, 4, and 9. There's no duplicates. This is a relation and a function. I'm abbreviating function, FCN, function. So it's a relation and a function. Now, we don't know what other pieces of data might show up, but what we have presented to us is a function. Look down the next one. 47, 45, 32, 19, 62. That's a relation and a function. A relation and a function. Next one. Oh, look at all this. I look down this column. There's so many repeating 8s I can't even mark them all. They do not all have the same value. So guess what? This is relation only. Again, a relation is anytime you have an ordered pair, anytime you have a left number related to the right number. So everything's a relation. In the last example, one more time, 1, 2, 3, 4, 5, no duplicates there, so relation and function. That's how you can look at a table and identify whether it's a relation, a function, or both. Now let's see what else we have here. This says mapping diagrams. A mapping diagram is really just this drawing that's on the left-hand side. You'll notice that a mapping diagram literally does no more than take the numbers in the input or left column and put them in the left oval. And then they take the numbers in the right-hand column and they put them in the right-hand oval, and then they draw arrows between them. Okay? The only thing a mapping diagram does for you sometimes is if you have more than one number, you'll see that arrows get used more than once or numbers get written only one time. So we have some examples there. You can pause the video and read the bullet points that are here and here. This definitely represents a function and a relation because you notice, same thing. If I highlight these, there's no duplicates, so relation and function. And then we're just about done. So we are just about done. Look at our examples on the left of a function. I come down the left-hand side. Those are my input values. And I notice that I only have a single arrow coming from each number. This comes from the 12. This comes from the 50. Notice how every one of those numbers is essentially only used twice. That's okay. The fact that these two come together and point both at the 17 doesn't matter. It's kind of like 4 hours costs you $12, but 4 hours and 1 minute also just costs you $12. That's okay. That's perfectly fine. So these would be y as a function of x. We would say this is a relation and a function. So we like that. On the right-hand side, that is not the case. Notice how as I come down through my inputs, the 83 is being used twice. That 83 does not match to the same two numbers. It matches to a 34 and a 23. That's not a function. This is a relation only. And the last piece. Look at these three examples and identify which ones are functions and relations and which ones are only relations. So I'm going to make a little relation only, and let's see if we have anywhere to put that, right? So I look here and I see 3, 14, and 5, the one on the left, but there's no double sets of arrows coming out of there. So I think that one's okay. I come over here and I see the 2 branching off. That's a relation only. If I come over to the third option, I see the 9 and the 8 kind of crisscrossed. That's just there to try to trick you. Notice there's no double arrow like we had in the middle. So in all of these examples, we would say relation and function. All right, this would be relation and function. So good luck identifying relations and functions.